All right. Welcome, folks. I see you have quite a number of guys on the stream. 5, that's awesome. This was on a very random session that I was set up. So it's good to see you. So let me just start off by welcome to this stream. This was a very random session that I set up. Mainly was the idea was to test this new platform that I'm trying to use for streaming. I'm paying them, but I'll just do the ad placement, free ad placement for them. It's called StreamYard. I'm paying for the premium one, so you don't see their logo there, but I'll still give them a shout out. I think it's a nice platform. I think it's working good. If you can hear me okay, let me know. Thank you, Peter. Welcome, Peter. Welcome, Ian. And everyone else, if you're there, just tell me where you're tuning in from. Not like a radio talk show, but you're welcome. And if you can hear me great, let me know also. If I need to adjust my mics, because this is the very first time I'm using this platform. I don't know how it sounds on the other end. So if I'm too loud or the sound is a bit low, let me know. I don't have a producer. I'm doing this end to end. So, but I'll get right into it. Today we were to review the book Software Craftmanship. I'll just share my screen and we can get started. But if I have any issues with the sound, let me know. So let me just get the right. Great. Oh, thanks. Sounds great. Awesome. I appreciate that. Yeah. So I share my screen. Let me just make sure I'm sharing the right screen. All right, we are good to go. I think I can see that you should be seeing the right screen. So let's go. So this, as I said, this was a very random session. I'm just doing it on the fly, but I thought as I'm testing this platform, let me use it for a useful thing. Maybe review a book that I was reading. I was actually in the middle of reading it, but I will share all the stuff that I've read so far. Most likely, by the time I get to where I'd reached, maybe the hour will be over, maybe not, but whichever way is gonna be okay. So let me just turn off the music for now, and then we can do this. Okay, good. So this book is, if you've read The Pragmatic Programmer, this is a book during its time. It's the time of that's like contemporary of The Pragmatic Programmer and the others. Yeah, so it is written during that time frame of early 2000s to 2001. I think Pragmatic also came out around that time, if I'm not mistaken. They were doing their 20th anniversary sometime back. Yeah, I don't need to go into those rabbit hole details, but just know that the ideas in that book was the same folks who had this movement they're calling software craftsmanship, and you'll understand why it was a movement. So it is by Pete McBreen. I didn't go. I like also going to the details of knowing about the author. So this author actually have not heard about him anymore. I actually like getting that background details, but if you can go do your Google search, you can maybe read more about him. But I also do that after this. I think this is one of the things that I skipped. Most times I like doing that, and also I like myself how I read books. Not sometimes people might confuse me like I'm really a deep reader or fast reader, but when you think of it, I'm actually a very slow reader, and but I love the details. I love reading prefaces. I like reading who wrote the forward, who is he, where he's coming from, and you get also to know maybe the person who wrote the forward was also another like author. You can go check out their work and stuff like that. So I like doing that. So this was I started from the forward. Uh, Mainly what I'll be doing in this book is I'll just be going straight to where I was highlighting and giving my thoughts and stuff. I see Mzee Kazi has joined me from Mombasa. Welcome. But basically, I'm gonna just be going over the things that I've highlighted, give my 2 cents, how it hit me, and I'll also be checking out. Let me just put my charts to be somewhere on the corner so that I don't have to. So I'll be able to see if you have anything, your views and stuff. I'll be able to see it from the chat. So be free to use the chat. I'm actually on it, and I can see the chat very clearly. So the forward, some of the things I highlighted. The book has some controversial answers. It suggests that we've lost sight of a simple truth: large methodologies and formal structures don't write software; people do. So you see this also in the chapter 1. Basically, the book was coming against the backdrop of software engineering. So software engineering uh, is the okay. We'll read about them in the book, but that's where the book was coming from. Software engineering was a big move then, but it was not working. NASA had used it, these big corporations, but projects were getting delivered late with bugs and stuff like that. So these guys were trying to rethink and come up with sort of a manifesto. And actually, there's a software craftsmanship manifesto, and I think I need to link it here. And there are some I have some links that I'm going to share. So stay with me till the end. There's some resources and stuff I'm going to share. So it's a very short manifesto. And also, you can sign your name against it. I think I have I don't think I'm on the top list here, but I have my name somewhere here. I did sign the manifesto some time back, but you can go sign that manifesto. Right there, I've put it in the chat. Yeah, but that's how this movement was coming about. So it's coming against the backdrop of software engineering that was failing then. So then here it says the craftsmanship is far more than a tag for high quality work. Okay. In the full meaning of the word, craftsmanship is a self-sustaining system in which masters arrange for the training of their replacement, and their status is based purely on the work you've done. So basically, it's just saying it's not just about the quality that, okay, I'm a software craftsman and it's about quality. It's a whole ecosystem of how do we sustain this quality through apprenticeship, through training of other in a craftsmanship there is a master and there are people we call apprentice, and also we have journeymen, people who are not yet masters. Like myself, I consider myself a journeyman. I'm not a master. I'm just getting towards like trying to master stuff. So that's like journeyman. So you can see apprentices, journeymen, and craftsmen all work together as a team. So you look at it in that lens. It's not just about like high quality, but it's more than the high quality. But high quality is part of it and very important bit of it. And then what really made the experience shine, however, was the apprenticeship that I served one of the graduate students took me under his wing. So he just talking about his apprenticeship journey and experience. Yeah, I'm a believer working with master with masters is the best way to learn a craft. I totally agree. I think you learn faster than you read a book. It's only that sometimes we have this challenge where you don't have masters around you, so you have to go the hard way. But if you are lucky to be in a team, if you're a junior engineer, actually some people asked me on LinkedIn whether this session was for senior engineers or juniors, but actually I think it's for juniors to encourage them to look for mentors or masters that they can work with. So, and sometimes it's hard to, just a tip for you guys if you're a junior, a tip for you is it's very hard to reach out to someone and tell them, hey, I want you to be my mentor. That tag comes with a very big responsibility. You wonder now, this person, if I'm becoming their mentor, we have meetings, we have this. So it becomes like someone might push back and say, oh, maybe say, oh, let's think about it. I don't have maybe the time and stuff like that. But you can have mentorship without ever telling them that you are my mentor. You just start off by saying, by the way, do you have a 30 minutes slot next week? I have some code that I'd like you to peer review with me and give me some feedback. That 30 minutes is done next week. And then another week, another month, reach out. Hey, do you have like 30 minutes? We can have a chat about this and that. Before you know it, that is mentorship. And that is actually how that person is your mentor somehow. So you don't have to really be outright and say, you want me, you want you to be my, I want you to be my master or my coach or my mentor. And actually, you can see that there's a difference between mentorship and apprenticeship. So mentorship is what we can, I think I've discussed this before in another podcast that they were asking me, someone was asking me about apprenticeship versus mentorship. So mentorship is what we can get now easily because you have this person you admire, but you don't work with them in the same company. Maybe they work in another company. They're another location. They're in the US, they're South Africa, Nigeria. The best way you can do is to use a bit of mentorship. And then another part that you can actually get apprenticeship easily versus mentorship, that mix is in open source. You can you can go to an open source repo that you like. You can get very great guys there, the maintainers. You can reach out to them, and that's how you can become apprentices under them. Yeah. So this is just a preface, but let me go to the meat of it. So I'll just be, as I said, oh, that was forward, and then there's a preface. There we go. So someone can know all the historic technical details of Java programming language, but that person will never be able to master application development unless he or she develops a feel for the aesthetics of the software. Aesthetics, I think, Mzee Jafet, if you're there, I think you like this. Conversely, once a person gets the feel for software development, the specific technical details become almost irrelevant. And that's very true. Like getting that feel. So I think what is just raising here is that there's the difference between the technical details, knowing about like, oh, this is how polymorphism in Java is done. This is why this is more performant than the other. Like all the jargon and stuff versus you having that feel of that and the aesthetic of software or software development. So it's a whole like more of a philosophy of how you view code and doing your craft. Yeah, Japheth says that's what we call test. And actually, Japheth is doing a lot of like philosophy, just learning about aesthetics and stuff. So I guess this will really resonate with you. And the term of software engineering was coined in 1967. I didn't know about this by NATO study group that recommended a conference to discuss the problems of software. So that then software was becoming a huge problem. You can imagine computers are starting off in 1950s, and then people are producing software, and immediately we have problems. And NATO is looking into how do we solve this problem, and then they said, okay, the answer is software engineering. Let's apply. Engineering has worked in the Industrial Revolution age, all this time in the early 19th, 20th century, when everything guys are doing manufacturing and all that. Engineering has worked very well, building bridges, building buildings. Engineering has worked. So let's apply the engineering principle into software development. And that's where they came up with the phrase software engineering. And they said the phrase software engineering was deliberately chosen to be provocative. Actually, in implying the need for software manufacturers to be based on the types of theoretical foundation and practical disciplines that are traditional in established branches of engineering. So yeah, just as I said, they're trying to provoke. So sometimes actually a true engineer, like electrical engineer or civil engineer, would be offended when you say you're a software engineer. Because software engineer was supposed to be more of like a provocation, like you guys need to style up. And it is very, as you'll see, it's very difficult to apply software engineering or engineering principles in software just on a one-to-one mapping, but you can borrow some good ideas from it. And then this book to be deliberately provocative in implying the need for practitioners to start paying attention to the craft of software development, like paying attention to that, pay attention to the people who do the software development. So you'll see a very big insistence on the people doing. So because engineering they deal with materials and very inanimate stuff, they really think about the people. It's about the process. But this book tries to flip this around and say the people really matter. And actually, if you look around for real, it's the people that really matter. It's the people that break things, the people that make you leave companies, leave teams, rather than the processes. You can go, if you get the right people, you can always fix the process. And you see it's in this book also. Craftsmanship brings with it the metaphor of skilled practitioners intent on mastering their craft. So there's an intention of mastering your craft, of pride in and responsibility for the fruits of their labor. Actually, this one is almost the summary of everything that is in this book up to where I've reached. So there is that intention of you're trying to master your craft. You're saying, like, I have to be good at this. Because of what? You want to be proud about your work. You want, even when you do your work, you want to be confident to leave your name there and say it was done by this person. Not you remember that there's those jokes of like you should write your code so that thinking that if the next person who takes over from your like inherits your code is not a maniac who can who will say like whatever you wrote, and maybe they can come after you and even kill you, because like they see some of the things that you are writing and wondering like what did this guy do here. So you should be able to say, okay, I'm the one who did this, and you can stand by it. Okay, and then rather, craftsmanship is a different tradition that happily coexists with the benefits from science and engineering. So yeah, it's about a balance. It's not, craftsmanship is not like we throw away engineering, we throw away science, and then we embrace aesthetics and arts, so to speak, but rather it is borrowing the best of both worlds. Then it says, just as blacksmiths transcend science and engineering with their skill and artistry, software craftsmanship can transcend the computer science and software engineering to produce great programs, applications, and systems. I totally agree with that. And they give an example of Unix. Like if you go, and another book is the Unix philosophy. You can just go, if you've never read it, you can go check it out. I think there's a new version like Linux philosophy. You can just read about how the guys who were starting off the Unix, like this Unix movement, how they were thinking about their software development or craftsmanship, and you'll understand what this person is talking about. And then software engineering is good at handling the problem of really large teams of 200 or more people, but it has little to say about how the individual in a team should practice their craft. That's very true. It's all about the process, getting this done by this time and this, but never about like this single person. I think they mistook, yeah, as you said, as I said earlier, they're carrying stuff from the industrial age, of processes and machines. So thinking that you can just have developers as cogs and then they'll just they churn out the work, but that ends up being very disastrous. And then maybe I'll just point out they may look glamorous from the outside, but from the inside, things are different. As the Kenyan proverb of vitu kwa grounded in a different. That's very true. Like you should not mistake like you've seen this software coming from this company X and thinking like it's really glamorous. Big teams, there's always issues and this actually this book really advocates for small teams that are agile and very nimble and the highly skilled teams. Then for me, the really test of a team is whether it manages to ship and then enhance and extend the application for years afterward. Very true. In big companies that's really about shipping and maybe deadlines, they will just ship. And that engineer knows that I'll ship and maybe leave the company and stuff like that. So you don't see the consequences of your work, of your mistakes. And then you have to pay for it because someone else will pay for that. Uh, but craftsmen, they really care about what really happens after. Shipping is not really the end. Shipping is just the beginning. You want to see like your software at work and how your users feel about it. And then shipping proves that the developer can make something work. Staying around for the next release allows the developer to experience the effects of the way that he or she built this application in the first place. Okay, so I'll just let it sink like that way. So I think it's just the same idea that I was saying, and maybe I'll just back up a little bit and just say that in this era of political correctness, so the word craftsmanship, there's the man there. Yeah, money is not about that men. It's about the men versus women. Man is just if you're a Christian here and you've read a book like the Bible and you hear that God created man in his own image, it is about the humanity, everyone. So craftsmanship should not feel if you're a lady, you shouldn't feel excluded. It's this term is just the general term for everything, for the old term. But times have changed. So if someone can feel maybe offended by the word man there, and you can just say craftship, which is a bit sounding a bit interesting, different, but that is the big idea here. Though again, it comes with this idea of I know. Let me not go into that rabbit hole. Let's go to the part one, questioning software engineering. I stay you, Jeff, and I'll come back to your comment. Question is software engineering. Let me just check the comment. I think it would be good to pause and see. We cannot undo injustice against women by doing new injustice against language. So, Kathy, that can only come from you. Yeah, that's true. That's true. Like, yeah, at some point, people just need to not be offended by things like, and we just work objectively towards. Let's just pause after I talk about this, like about equity and all this stuff. At some point we just need to pause and see like what is the best way that we can bring more women in software engineering, as opposed to trying to make it antagonistic and saying, oh, this sounding a bit of this and that, like language and all that. Like even it came to like during the days of Black Lives Matter, it came to a time when people were saying, oh, let's not use master branch. It is connotating the idea of master slave. So this language stuff, guys, for me, I'm always believing that we can go over the language. Like we can go and do practical things other than just trying to make people happy with wordings and stuff. And people who are offended by language, they need to work on themselves on that. Like if something that has been there over and over, how many times are you going to change this? Because things are going to keep changing. Yeah. So that is that. But we should actively work on equity and bringing more women on board in whatever we are doing. Like if you're starting a team, you're doing a project, think about like, hey, who can be interested, mentoring. Like sometimes it doesn't have to be you. By the time you're getting to like senior level, already the battle is already done. But you can always get this, or can catch them early when they're getting out of campus, trying to steer them towards the right direction. No, not really getting out of high school, choosing the right courses for college and also high school. Also by Form 2 in Kenya, already the battle is done. For me, I always say that if someone is not taking a STEM, like sciences, like maybe physics, already they are cutting off themselves from a big chunk of STEM related courses that they could go into that are already male dominated. So the battle already is won is done. No, not won. Well, I don't think it's about winning or losing, but the battle is done by Form 2 when someone is choosing the courses. So we really need to work on this problem of equity and bringing more women on board, as opposed to just trying to be political and trying to just armchair reviews and stuff. Yeah, that's my small rant-ish, end of rant. Let's go back to part one. So let's do this. So first, let me say the book, so that you just know where we are going. The book has five main parts, okay? And actually, with this, because I read from this orally, and at some point, because of the navigation, I almost thought that I finished the book. I was just finishing a part. So yeah, just be careful about that. So the book has 19 chapters. So these are the parts. Questioning software engineering, there's these chapters, 4 chapters. Then there is software craftsmanship. This is like the central piece now, where he's making the thesis of software craftsmanship. And then there is chapter 3, implications. This is where the okay, demo gods. Chapter 3, it's about now the implication of software craftsmanship. This is where I reached at chapter 9, which we'll get there. And then chapter 4 is repositioning software engineering. So going back to software engineering, remember this was an answer to software engineering. And then you're saying, let's go back to software engineering and reposition it. And then the fifth is the fifth section or part is what to do on Monday. I really love this title. Like I felt like I should read it being my weekend. Like, what should I do on Monday? So this I haven't read it that yet, but sounds like a very good one. So maybe after this, just go and jump to what to do on Monday. That's a nice one to go over. So let's do chapter section 1, and looks like this is the section we're gonna do for the day and close, because I see we are halfway through on our time. But let's see where we get. Okay, part 1. I'll just be going to highlights, but because we're not reading the whole book with you, it's not even possible. So I'll just do the highlights, and then the idea is to see whether it is a book worth your time. If you can go back and just read it, everything. Yeah. So I might not be doing actually the right justice to just jump over the highlights, but that's the best I can do now. Then some projects are well suited to the software engineering approach, but most are not. Yeah. So that's, I think that is the idea of, if you're building like mission critical software, like the ones that launching missiles, the airspace, his missile is really mission critical, but I'm talking about rockets. But also missiles is mission critical weaponry, because you don't want to make mistakes and harm the wrong people or stuff like that. And 2, if your medical devices, stuff that are to do with human life, it's really critical, like the ones that are at the edge of it. But at the end of the day, every software is sort of mission critical, because it's a chain of software. So if you make a mistake on your paging device, paging software, and then there's a doctor who was on call who was supposed to come and save a life, and it doesn't page right. So already that is mission critical. Somehow someone has lost life, but you see, it's a long shot to make that that argument. Okay, so yeah. So basically, mission critical, they're saying you can now apply rigorous software engineering principles or engineering principle to it. In 1968, a NATO conference identified a software crisis. As we read that was in the, is it in the forward or yeah, forward. NATO conference identified a software crisis and suggested that for large, high-quality software applications, software engineering was the best way out of the crisis. Since that time, the need of the U.S. Department of Defense (DoD) have dominated the conversation about software engineering. So you can see that this is always coming from the NATO guys, the Department of Defense of the U.S. Somehow it's the U.S. that has dominated this field. Yeah, I think they did the right. I think they did the right investments earlier on. They were betting on this stuff very early when other governments were not really betting on them, and that's why they made like very big advances in ARPANET, which ended up to be internet. Also in cryptography, some of the cryptographic algorithms are not even, they have export restrictions. You cannot use them in some countries. Yeah, so they had a monopoly on that, and they're trying to shape this, but they don't have to be the only ones shaping like these conversations every time. Yeah, that was one that I highlight that I made. Let's go and see. So chapter 1, understanding software engineering. So this section is just about software engineering first, like digging into software engineering, and then the second section is about digging now into software craftsmanship, the other side of the coin. So the paradox of software engineering. So yeah, you're just saying that this was like using a very huge, like applying a solution, like an overkill solution, basically. Like you're saying that for software engineering, those kind of projects that are like Safeguard, that's one of the projects I think in the DoD, are extremely rare. Like those kind of humongous projects, and then very large projects like with thousands plus staff years helped to define software engineering. You see, this is where software engineering was coming from. It's coming from these huge corporation kind of projects, like industrial projects. And then a defining characteristic of this type of project is that initially the software developers have to wait for the hardware, and then by the end of the project, the hardware people are waiting for the software. Software engineering grew up out of this paradox. Yeah. So that was the time. The time was that you start designing even before you get the hardware. The hardware is still being made by by the manufacturers. So you're doing stuff like, that's why you had to have very strong contracts, strong specifications, so that if you're building this way, you know these guys want to break their contract. This will be the right way they do. But I know it's a very different edge where hardware is there, it's already there, and actually it's people waiting for the software. By that time, people are waiting for hardware, and then when you produce your software after the hardware is come, and then the hardware guys now waiting for the software to again to test. So it was a paradoxical situation there. So that was like, we're talking of the 60s, 70s time frame. What did developers do while waiting for the hardware? So in that context, it made sense to define a rigorous requirements process with the goal of producing a detailed requirements specification that could be reviewed and signed off. So once the requirements were complete, this documentation could be handed off to a design team, which could then produce an exquisitely detailed design spec. Detailed design reviews were a natural part of this process, as there was plenty of time to get the design right while waiting for the development of the hardware to advance to the point where an engineering prototype could be made available to the software team. So you can see very different times when actually even here the software was being done by in a very niche team. Like very few people are doing software engineering then or software development. Hardware is like scarce and very protected and only available to very few individuals. So that's the backdrop of software engineering. And then how did developers speed up software delivery once, sorry, Bono, once the hardware became available? The short answer is throw lots of bodies at the problem. This was the human wave approach that Stephen Levy described, and that sorry, and that can be seen in the manpower figures reported from the Safeguard project. So you know, Safeguard had about 1,000 plus staff. So it's just about getting throw a lot of bodies to the problem, and of course that one you'll see it's a disaster. It will end up as a disaster, and it has been discussed in another book called the Mythical Man Month, which I think this book also has quoted it a number of times. So implications for the development process. A great way to control changes from the bottom is to define a project hierarchy that puts the analysts at the top. So that is what they are thinking. Put the analysts at the top with the designers below them, and then programmers at the bottom of the heap. This structure is maintained by promoting good programmers to become designers and allowing good designers to undertake the analyst role. So that was how they're structuring things, like make it like management structure, and programmers are just there to implement. Just give them the spec and they'll implement it. And that one, as you know it, if you have done software for some time, you know that's failed like miserably. You have to include these guys from every step. Like they have to know where they're what they're solving for, as opposed to just being given a spec. And then the modern definition of software engineering. Software engineering is now an accepted academic subject and an active research field for universities. The focus for software engineering project is on a defined, repeatable approach, as exemplified by IE definition. Software engineering, so this is a definition of what SWE means. Software engineering is the application of a systematic, disciplined, quantifiable approach to development, operation, and maintenance of software. That is the application of engineering to software. So basically, this systematic, disciplined, quantifiable approach, this is what you call the engineering approach. And that's what now is being applied to software development. Now we call that software engineering. It's not a bad thing, but it has some failures, which you'll see as we go. And they're saying it's very effective also for, as you said, safety critical systems. Very effective. And it's required. Whether you like it, if you're building for GE and all these other guys who do like for healthcare and stuff, there's always standards that you have to follow, and there's no way around it because they cannot afford to make a mistake. They lose lives. So the last three versions of the program, each 420,000 lines long, had just one error each. So this is like like very high bar of quality. The last 11 versions of this software had a total of 17 errors. Commercial programs of equivalent complexity will have 5,000 errors. Yes. So you can see, like for very niche products, software engineering is good. But this other one, there's an answer for these other ones that are getting 5,000 errors and above. Money is not a critical constraint. The group. So again, this is another thing that we forget. It's not that people are lazy or they just want to produce bad software and brags. It's all about also about the money. Like you guys like NASA, money is not the problem to them. Like they'll throw a lot of money to a particular problem and the project they're building, where you can afford to have guys go over every single line and everything and just check and test and do everything. Make sure that the software is at the highest quality as possible. Though even with that, still there have been failures. You've had to submit Challenger and all other things that have failed before, like disastrously because of software errors actually. But still, you cannot overlook the good times when they have really worked well. So there was this time the movement what they call the good enough software. Like once it's just good enough, just ship it. Don't worry. And I think that's surely the idea of everyone, most of us. It's good enough. Let me ship that. Uh, so I'm going to deliver a system to you in 6 months that will have 5,000 bugs in it, and you're going to be very happy. So this is like a quote from one of the guys who started off this good enough software movement. So good enough software is a logical extension of the ideas of software engineering. It represents the engineering trade-off between resources, schedule, features, and defects. So you have to like do a trade-off, like what do you want between, do you want defects or pay more money without defects, or pay less money and more defects, stuff like that. So trying to hit that balance. And then resources are constrained by the need to make a profit. Again, now enter capitalism enters group chat. Resources are constrained by the need to make a profit. So the engineering trade-off is made to shrink the schedule by spending less time removing non-defects. Yeah. And then, is software engineering a good choice for your project? Yeah, that's a question you need to ask yourself. And when I'm a passenger in I saw this an example. When I'm a passenger in a fly-by-wire aircraft, I want to know what that a systematic, disciplined, and quantifiable approach was taken to the development and verification of the flight control software. After all, it will not be very comforting to know that the software was developed by the lowest bidder. So you see, now in talking about critical stuff that really human life is involved, like at the edge. Everything, of course, human life is involved, but I think where like it's one mistake and human life is lost immediately. People want really like to apply the rigorous software engineering principles. But as you heard, it's not like every software that needs that kind of rigor. By that doesn't mean that now you become sloppy, and that's now the answer to what software craftsmanship brings. And then chapter 2, the problem with software engineering. How are we doing on time? So 15 minutes. The biggest problem with software engineering is the assumption that a systematic, disciplined, and quantifiable approach is the only possible approach. Yeah. So you think that is the only way we can build software. So you say that that's a problem. It's not to view it that way. It's a wrong way. So there is these two things that he raises in this book about defect potential and defect removal efficiency. That this is why the trap that you'll get into anytime. So the total universe of errors or bugs that might be expected in a software project, and defect removal efficiency is the percentage of potential defects eliminated prior to releasing a software project to customers. And then we will not be talking about the defect potential of a project. We should be talking about the defect potential of our developer. So you see, he flips this coin like, why are we talking about the project? How about the person doing this? So that's like there's been the argument about this. The whole of this book is all about like, let's flip it. Let's talk about the person doing the craftsman, the person doing the project. And then the conclusion is simple. If 200-man project has 25 managers who are in the, so these are quote actually from one of the other books. I think Fred Brooks, that's a mythical man month, but they'll go look at for that book. I'll also link it somewhere in this description. The mythical man month, I think that's the title. So the conclusion is simple, that if there were 2,000-man project has 25 managers who are the most competent and experienced programmers, like now you've sort of you have promoted the best engineers, which is a wrong thing to do, to become managers of these other folks. And then who are the most competent and experienced programmers, fire the 175 troops and put managers back to the programming. So this was like just trying to make like a hyperbole out of it, but that is how he was looking at that idea of just work with the best. Don't try and say let me just get average folks, and then with good managers, then they'll get the stuff done. The key problem with software engineering is that it lets us forget about the people. So yeah, it's all about the people doing the software development. The implicit promise of software engineering is that if we can just define a systematic, quantifiable process, anyone can be successful at software development. This idea is wrong. Yeah. So it's not just about processing, it's about people plus process. And I think it is people over process, I guess. That is the thing. And then as we automate successive parts of the software development puzzle, we find that the complexity and the difficulty don't go away, but simply move around like a bubble under the carpet. Yeah. So you solve for one part. Yeah, I think I don't want to go into that. Like I'll get lost there. But I think for guys here who have worked on stuff, you can see like how you move, you just move around complexity. You can never run away from this problem. Like you move complexity from one side to another. Even talk of like if you go to microservices architecture, you simplify one side, you bring complexity on management, DevOps, and all that. Uh, as we software engineering has focused our attention on the mechanical parts of software development, and in the process devalued and de-emphasized the rest. Yeah, the hazard of good enough software approach. So I thought that problem of good enough software approach, it has a number of hazards that the author highlights. So I'll just highlight actually the titles. Is software more critical to your business and yet becoming bloated and bigger, buggier? I can remember the days when a word processor fitted on a single flop. So I highlighted this because it hit me like different here. And now it seems that we will soon be seeing applications that won't fit on a single CD. This is early 2000s. And now you can laugh because right now any software, WhatsApp, whatever, any software is like huge. And you just wondering like, people are saying, there is memory, let's use it. So, but remember the guys in the 20th century who are working very constrained stuff, and they are producing very nice software still, that is still even around up to now. We're still depending on. So somehow our times have changed where I don't know, we have not pay attention to, because maybe abundance brings like knowing that you have enough RAM, you just think that you can just use the whole of it. And most people usually think that you're the only app running on that, so on that computer. Yeah, I'm talking to you, Chrome. And what happened with Chrome, and people are talking about how it eats RAM. So I think we need to just rethink about uh, building, bringing back constraint and building nimble software. I think I'm still a big fan of that. Like I miss the days when actually I remember I used to install Windows XP from I think it was one floppy disk of the 2. Was it how many MB? The 2.4 MB or one floppy disk, and then Windows 2000 was a number of floppy disks that you change, like 4 of them, just 4, and the other one was just one floppy disk, and you have a whole operating system. So yeah, so times have changed, and I guess it's just maybe how we've been doing software. So for many Shrinkraft application, each release seems to require that you buy more memory or get faster machine. And most of the new features don't work very well. Very true. So there's some questions asking here, does your software look nicer but prove much harder to use? Are projects taking longer and delivering less than promised? Do the developers seem unresponsive to your needs when you report a defect? Seeing that the good enough software approach is hazardous because it perpetuates the myth that defects are inevitable. Yeah. So you're saying that it's a myth, like just saying, software must always have bugs. Like, and there's one quote from Edgar Dijkstra, I think that was somewhere that I highlighted, maybe somewhere in the next section. Uh, People use that as an excuse to say, okay, we can always have bugs in the software. I think we'll see it in the next section. Uh, so by separating the activities of coding and testing into distinct phases, the good enough software approach guarantees that the application will contain lots of defects. Yeah. So He's also arguing against that thing of having testers on one side, having developers on one side. I think if you've been around for some time, you'll know that that one fails all the time because developers will just build, not caring, like, see, testers will test and find defects and we'll see how. And then again, communication, now bring back, now let's fix this bug. And then before you know it, you have a backlog of bugs to need to be fixed. And then that's why you say, this bug, let's see, which ones are P1s? Which one are P2? Let's deal with P1s. Let's leave P3s. Let's ship good enough software. So that's the problem that he is raising here. Shipping software with non-bugged is not a good idea. Yeah, he's raising like, when you're shipping, don't say, we know these bugs like that are there. It just means you don't really care. So, but I understand that sometimes budget, economics and stuff, but this book is trying really to come against that idea of good enough software, which we'll see in the next sections as we go. It says that you don't know how to fix the mistakes you have made in your software. Even worse, it suggests that you do not care about creating the quality, reliable software. I think that's what I just said there. Then, what is the alternative to software engineering? So he said, before we can approach these issues, we must first break free from the mechanical software engineering metaphor and understand the true nature of software development. So I think we can close on this chapter 3. I thought we'll do the whole book, but I see it's gonna be an interesting. So I'm okay doing this like over every Saturday. I'm good. My Saturday mornings are always good. So I will close on chapter 3, and then I've just seen that, folks, you've been 5 guys that you joined. You stayed with me, so this is a good sign. So thank you for staying around, and I can close on chapter 3, and then we can pick up from chapter 4 next week, or I think it should be next week. I should be able to do this in the morning. So, okay. Understanding software development. So typing the code has never been the rate limiting step. So physical analogies are not really appropriate. Yeah. So I think we forget that. I think over time, everyone knows this, that the code, writing the code is not the problem. The solving the problem is the problem, or is the thing that you have to look out for. So here, to be useful as a metaphor, a concept has to be well known, if not well understood, by people who will be using it. This reason explains why the mythical man-month, so that book that we've been to, Fred Brooks, problem still exists. It seems to so simple. If a software project is late, just add more people, it will be done sooner. Projects are still making this mistake more than 25 years after Fred Brooks pointed out. This is 25 years, so we're talking about 45 years now, because this is 2001. Still happening. After Fred Brooks pointed out that this simple idea is great way to make the project even later. Like Fred Brooks argues that if 3 engineers can, or 2 engineers can, I don't remember the exact quote, but let's say 2 engineers can do this project in 3 months. 4 engineers will do this project in 7 months. Because you forget about the little nuances of communication over communication, paying for communication, overheads and stuff like that. So this is already discussed in detail in Mythical Man-Month. I don't need to go into that, and this is a good book that I can highly recommend. I think I will try and also link it here in the description. Okay, so all the unknown are worked out during the design process so that the actual production of cars is a defined, well-known, repeatable process. So like he's saying about cars, so cars is opposite. Cars is like, it is once they have designed and everything is done, and even they've designed the production line and how the cars will be produced, the rest is just easy peasy. It's just trying to run through the production. So the design first is the hardest. No, sometimes even Elon was saying the design is the easiest, and then the hardest is the engineering, like now getting that manufacturing engineering. So but I mean, software is a different. Software distributing is much easier. Production is much easier than the development part, because the development is where it's all about unknown. So they're much better than we understand design and intellectual tasks. So software engineering metaphor fails because we understand production, a metaphor, a mechanical task much better than we understand design and intellectual task. So yeah, so you're just saying that is the problem of software engineering. Yeah, so development large software system must be treated at least in part as a learning, communication, and negotiation process. So I guess this really hits very well from people here who have done this for some time. That even for you to grow as an engineer, you need to master these negotiations, communications, learning, growing your skill. So this thing is where is everywhere. In when you look everywhere you look around, you'll see it. That software is not just about the writing the code. The code is just a part of it. Uh, yes, and then talk about teamwork. So development requires teamwork. I think this is well-known fact. I think I don't need to ever emphasize that. There's the division of labor work for software development. Of course, here the answer is no. So a good one is 19 programmers who shaped. Oh no, sorry, not this one. Where is that? As Fred Brook pointed out, when a task is dominated by communication between the workers, adding more people slows down the project. So because communication is needed in software development, because I think many people attest that, like you working alone on a particular project, you can actually do this project maybe faster sometimes. The moment you bring one more person, three, that communication overhead, it slows down the project. But it's important because you alone you'll be overwhelmed. Also, you'll do something in one with one kind of lens. You bring more people, they bring in different views, which are good, which makes the software great. So you still need people. You need a team, but it is slower, but it's gonna give like antidotes to that. So one size does not fit all. As I get older, so this is a good quote. As I get older and cranky, I find myself more and more exasperated with the great inflexible sets of rules that many companies try to pour into the concrete and sanctify as methods. The idea that a single method should govern every two different projects is highly suspect. The difference between projects are much more important than the similarities. So the differences, so this is where you're saying process trump everything, process over everything. But this one is like, no, 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 no. Processes are just one bit and it doesn't always work one size fits all. Uh, yeah, so that's the last. Yeah, yeah. You just think about like getting this was a joke sort of. The last one always causes me to smile because it reminds me of James Smith's advice of for improving delivery speed, start earlier. But if you want to deliver faster, start earlier. Started yesterday. So getting the project started, like you're just mentioning here, the problems that are always arising. Like there's so many scheduling, design, and code reviews, debugging, getting the project started. Like it's just even a whole big problem when you're working on new software. Yeah. So this is. I think I can close here. I wanted to at least leave you with the stuff that I just picked up, some interesting stuff. This is really not about the software craftsmanship, but this is just some stuff I read of I put on the charts on how Linux started. Like a bunch of just university kids who just were doing this kind of stuff. And then this is a good like example of software that was really well done. This SQL, like it's still there years and years later, still going strong. So I've put that on the chart. These are very good um, what is this podcast I listen to about SQLite. And then I have a list of books that just around software craftsmanship or just software craft. You can just check out that playlist. You don't have to be on O'Reilly. You can just get the titles and you can get them from wherever you get your books. I won't mention you guys will pirate. And then there is this conference is no longer happening since 2018, but it is a software craftsmanship conference that used to happen. So there's very nice talks here. You can just hear like guys who the same like philosophy or the same thinking. You can go check them out. And then the one that I loved most was this one, this specific talk on I think it's called let me see. They're not talking about software craftsmanship and the safety critical world. Yeah. So this guy builds software for safety critical stuff like medical devices and stuff like that. And they're just talking about how they apply software craftsmanship still on that. So, and then this guy called 8light. This is the company that is still doing a lot of software craftsmanship ideas. Those are the ones I know. Like I know there's so many more. And then there used to be a guy that I used to love called Pivotal Labs. If you remember Pivotal Tracker, the guys who were maybe Tandela, we used to use Pivotal Tracker for our project management. But I just noticed that I had missed the memo, like they were acquired by VMware, like sometime back in 2019. So, but I know that this is one of the companies that was really pedantic on software craftsmanship and the idea of apprenticeship and pair programming, extreme programming, and stuff like that. They were really pedantic on it. It's, I think, it's a Canadian firm acquired by VMware. And then this is the code is poetry is a term that WordPress started just about clearing. Like, I just thought that you can read that. Also, it's a good reading there. This also is not about software craftsmanship, but it's just Zen of Python. I think if you read the Zen of Python, you understand that it is someone who wrote it. He cared about the craft. So I'm sure that there's some of that those philosophies still there, philosophies they coincide. Okay, 2004, maybe we are doing the same movement time of software craftsmanship. So Zen of Python, I think guys who do Python, you already know Zen of Python. And of course, I shared with you the manifesto of the software craftsmanship manifesto. Yeah, so I'll end here. Thank you so much for for coming on this on this session. I've not planned it. Just said like let me do it, and I'm happy to see you guys, and I appreciate you. So have a good weekend. I'll see you around. Please feel free to swing by next week. I'll be doing the continuation of the same book, and let's see how it goes. Have a nice weekend and God bless you. Thank you.